right? So after that, I mean, we really did talk about one of the conic sections last time. It was circles. It's not much to circles, so we threw in that little bit about completing the square. Right now we'll spend one day each on parabolas, ellipses, and hyperbolas, the other conic sections. Today we do parabolas, which is probably, it's the one that you've kind of already done before. When you did quadratic functions, you did parabolas. But we do more than that in this. This is a lot more than what you would have ever done in a chapter about quadratic functions. Right? So just like we had a definition for a circle that sounded like the set of all points that are equidistant from a point, right? You have the same kind of definition for all the other conic sections. For a parabola, it's the set of all points that are equidistant. Again, what do you think equidistant means? Same distance, right? Equidistant from, I got to get my pen going here. From a fixed line, which is called the directrix, and a fixed point, which is called the focus. Now, we're kind of familiar with the shape of a parabola. It's like a U, right? So if you look at this shape, which is our parabola, the focus is sitting on the inside, right? Parabola is wrapped around the focus. The directrix, right, is outside of the parabola. Remember, when it said equidistant, it means for every point on this parabola, if I measure the distance from the point to the focus and the point to the line, it's the same. That's how we define that. So they just did a couple examples here, right? This point here, if you say this is the distance D1, then this is D1. If this is D2, then this is D2. Right? The vertex of a parabola is halfway between the focus and the directrix. Right? It would have to be, right? Because the vertex is the point on the parabola. It has to be equidistant from the focus and the directrix. So it's halfway between. So what else is in here? The axis of the parabola is the line passing through the focus. Okay. You know, depending on who your teacher was, when you did parabolas before, you probably talked about axis of symmetry. You know, that's kind of what they're referring to here. We don't really mess with that so much here. But the axis of symmetry would just be this vertical line going right through the middle. You know, with respect to that line, this thing is like the same on the right as it is on the left. It's symmetric with respect to that line. So they didn't even mark that on the graph, right, to show the axis. Or even, they'd even call it the axis of symmetry, like we've done in the past. Sometimes when they use these kinds of definitions, the set of all points kind of things, they'll use a word called locus. The locus means like the set of all, right? The locus of points. I'm kind of surprised it's not in their definition. You know, we'll see later that parabolas have special characteristics in the real world that are useful in ways that you are familiar with. You probably use parabolas in your life without even knowing. Okay, we're good with that? Okay, so we have standard equations or standard forms of equations of parabolas. And unlike when you've dealt with quadratic functions in the past, in which case the parabola is always opened up or down, now we're going to have parabolas that could open to the right or to the left. That's why we need to have two different equations. Now, if you look at the equations, there's some familiar things in the equations, right? At least in terms of the letters you're looking at. You know, this one here says a vertical axis, which means it's opening up or down. You can see it's got an H and a K in it. Well, we just dealt with H and K, right? That was the center of a circle. For a parabola, parabola doesn't have a center, it has a vertex. So the HK is the vertex. right? Vertex at HK. And besides that, it has a X and a Y. Well, those are the variables. They will be in there in the end. But it has a new one that we have not seen yet, right? If you dealt with parabolas before, you did not deal with this letter P. And you can see that underneath it's defining this P as what they call directed distance. On the next slide, you'll see what that is. Remember how we said the vertex was exactly halfway between the focus and the directrix? P is the distance between the vertex and the focus, or the vertex and the directrix. But we'll see that on the next slide. So this one, as complicated as it looks, is the form of it that you've dealt with before, right? This is y equals x squared, which is a function, right? The second one is the horizontal. It's either opening to the right or the left. It's x equals y squared, right? We never dealt with that one. That's not a function. I mean, if you could just imagine a parabola that opens to the right or to the left, it would fail a vertical line test, and it does. Okay. The equations that they give below are the special case that the vertex is the origin. So if the HK equals 0, 0, you get this. Or 0, 0, you get this. Which is a much simpler equation, right, at that point. Right. Let's see, what else? So when we put these into standard form, right, notice that they are solved for the squared term, right? To put them in standard form, the squared term has to be alone on one side of the equation, and everything else will be on the other side of the equation. So we will, in time, we will complete the square to make this perfect square trinomial on the left, and then we'll make sure that everything else is on the right. And what else? I think that's it. Let's look at the picture. This is the first equation. Vertical axis means it's opening up or down, which is the version that we looked at. That's a function, right? Passes a vertical line test. Right, here's the standard form of the equation. And you can see now we can see what that P is, right? See how the P is labeled here? It's vertex to the focus, which means it's also vertex to the directrix. If this has the coordinates of HK, right, then in order to go up P, then the y coordinate now is K plus P. Okay, because it's opening up, right? When we've dealt with our other versions, like standard form ax squared plus bx plus c, when the a was positive, it opened up. When the a was negative, it opened down. Here, when the p is positive, it opens up. When the p is negative, it opens down. But everything else is pretty much the same. Right, this is the horizontal version, the one we have not done before. Right? I mean, you should not recall ever doing x equals y squared. Y equals x squared? Yeah. X equals y squared? No, we didn't do that one yet. So this is the new one. And it makes sense because we didn't look at parabolas that open to the left or to the right. You know, clearly not a function. Doesn't pass vertical line test. Look at the the vertex is here. The focus is inside the parabola. It is P away from the vertex. The directrix, right, is on the opposite side. It's P away from the vertex. Right, this time, if the coordinates of the vertex are HK, it's the x coordinate, which is being added plus P, H plus P. And this time, if the P is positive, it opens to the right. If the P is negative, it opens to the left. See what's next. All right, so these are the kind of things we do with this. Right? And what I think every problem I'm doing here is like an even number problem next to an odd number problem that you are going to do. And I've copied the directions that are there with the problem. There should be no confusion about what's being asked. And you're going to have an example like worked out right there with it. Right? So for the first, it says, find the vertex, the focus, and the directrix of the parabola, and then sketch the graph. Right? This is the equation that we're starting with. So first thing, looking at that, is this going to be vertical or horizontal? It's horizontal because it's the x equals y squared, right? So it's either to the right or to the left. Is it to the right or is it to the left? Remember, how did you tell? Right? It's horizontal. It opens to the right if p is greater than 0. It opens to the left if p is less than 0. Okay, where do you look for the p? Right? It's the coefficient of the x term. So look at that. Is it positive or negative? It's positive. It's positive 3. So it's going to open to the right. So this is going to be, right, it is horizontal because x equals y squared. Opens right because p is greater than 0. Right. So what is, first of all, what is the vertex? I mean, remember, they gave, actually, their original standard forms, they gave us 2, right? And they gave us 2, horizontal and vertical, or sorry, vertical and horizontal, and then there was 2 below, which we'll see this is actually the case of the one below. But if we just compare it to the one that they gave us at the top, it looked like this. Y minus k squared equals 4p x minus h. So when I say, what's the vertex? It's saying, what is being subtracted from y and from x? Right? Is anything being subtracted from y before you square it? So it's 0, right? Same thing over here. You got the 3 times x minus h, or 4p times x minus h, but here there is nothing being subtracted from the x. So what is the vertex? It's 0, 0. It's the origin, right? So the hk in our case here is 0, 0. And now we need to know the p, right? Well, remember, that number 3 is not p. It's 4 times p, right? The formula says 4 times p. So we have to say that 4p equals 3. So p equals 3/4. Let me do this. I'm going to make this like a 1, 1, 2, 3, 4. I should have made that bigger, but that's okay. 1, negative 1, negative 1. All right, so this would be the vertex is at 0, 0. It opens, as we said, to the right. Right, so we know the parabola is going to go around it like this. And we're not plotting points, we're just sketching in a parabola that goes to the right. The vertex should be p inside, a distance of p inside the parabola. So starting at the vertex, and if this is 1, then 3/4 would be right there. That is 3/4, 0. And where would we look to find the directrix? Remember, we're dealing with that one. If the focus is here, where's the directrix? On the opposite side, right? Outside the parabola, on the opposite side of the vertex. Right, so we're going to come over. If this was 3/4 inside the parabola, then the directrix is 3/4 the other side, which would make that x equals negative 3/4. So we found the vertex, we found the focus, we found the directrix, and we sketched the graph. Good. Mitch, ready? Okay. From the same set of problems, a little more complicated this time. We've got something is being subtracted from the x and the y, so we will have a vertex that's not at the origin. So first question to ask is this one opening horizontally or vertically? It's a vertical because it's y equals x squared, right? So it's either up or down. Okay, which one is it? How do you tell? If this number here is positive, it's up. So it's up, right? So this is vertical because it's y equals x squared, right? It is opens up because p, it's actually 4p, but same difference. P is greater than 0. Right? Is this thing in the standard form? I mean, remember, the standard form looks like this. X minus h squared equals 4p y minus k. Remember, it should be solved for the squared term on one side, and then everything else on the other. You know, if there's a coefficient on y, got to be factored out. And everything's in place, so this is already in the standard form. What is the vertex? No. What is h? It's not 1/2. What is it? Negative 1/2. Remember, x minus h. It's got a minus in the formula. When you see plus, that means h is negative. Okay, and then what is the k? It's 1, right? Positive 1. Okay, how are we going to tell what the p is? What is the value of 4p? 4p is 4. So make an equation. 4p equals 4, so p equals 1. So with all that, graph, negative 1/2, 1. I'm going to make this like, I'll do it again like negative, no, let's see. We'll go negative 1, and it opens up. That's not going to look. I'll make this negative 1, negative 2, negative 1, oh, sorry, positive 1, positive 2, 1, 2, negative 1, negative 2. So we're at negative 1/2, 1, negative 1/2, positive 1. We should go p, right? We have something that opens up, so it's better probably to sketch that in right away. And then we're going to put the p, or the focus, a distance of 1 inside. So we're going to go up 1 to here. There's the focus. Did I put that on the last one? You know what I didn't do? I didn't say that that's the focus. Right, so on this one, the focus is here. What are the coordinates of that point? Negative 1/2, 2. And then where will we look for the directrix? Right, it would be down here somewhere, right? It's got to be the same distance that this was inside. The directrix is outside. So it's right here. And what's the equation of that line? Y equals 0. Right, so we did vertex, focus, directrix, sketch a graph. Right? You don't have to plot points. You don't need to make a table of values. You just need those parts. Okay. Okay, now this is where it's not in the standard form, so we're going to have to do something to put in standard form. What do you think we do? Complete the square. That's why you got to complete the square. Okay. So this will look a little bit different because we're not aiming for that same vertex form that we did in the homework from last night. Now we're looking at the standard form, what this textbook is calling a standard form. I mean, you could tell some things right away. I mean, is this going to be vertical or horizontal? Is it going to be y equals x squared or x equals y squared? It's definitely going to be x equals y squared, right? There's only one squared term, and it's y squared. So we can tell right away that this is going to be, don't do that, right? Horizontal. I'm not going to say whether it's going to be left or right until I put it in the standard form. I could tell what's the value of p. Right? But what I know is I need to put it in this form, right, which is the y minus k squared equals 4p x minus h. So all I want on the left side of the equation are the things that will contribute to that perfect square trinomial. So I'm going to write down y squared minus 4y on the left, and I'll move the 4x to the right. Right? Then I'll complete the square on the left. Right? What do I add to the left side to complete the square? Positive 4, right? Half of negative 4 is negative 2. Negative 2 squared is 4. Right? Now, what am I going to do to balance out the fact I added 4 to the left? Add 4 to the right. Right? These are the things that are balancing now. Okay, now, what's on the left can be put into the y minus something squared. What will that y minus something be? Y minus, remember it's half of the middle term, 2. And on the right, you could factor the 4. Since there's a coefficient on x, we need to factor it from both terms. So that'll be 4 times x plus 1. Okay, now that's in standard form. We completed the square. The squared term is isolated on one side. Everything else is on the other. Factor the right-hand side. Okay, we ought to be able to tell now what's the vertex. Oh, first, is it going to open up or left or right? To the right, because that's positive, right? So that's greater than 0, therefore opens right. Right. What is the vertex? Negative 1, positive 2. And what is the p going to be? Right, the p will be 4p is 4, so p is 1 again. So let's see. Probably makes sense to do it like I did the last one. I'll make this like 1, 2, 1, negative 1, negative 1, negative 2, negative 3. So that we're at negative 1, 2, opening to the right. Negative 1, positive 2, opens to the right. How far inside of that am I going to look for the focus? P is 1, right? So go from this point, go 1 inside, right there. That is the focus. So that coordinates of that are 0, 2. And then where will I look for the directrix? On the opposite side, right? So that was 1 inside, then you go 1 outside, sketch a line. And what's the equation of that line? X equals negative 2. So when it comes to parabolas, you got to complete the square once, right? When we do all the other conics have 2. Both x and y are squared, so you might have to complete the square on both. This one is just once. Okay, then these come from a different set of problems. Again, the directions are these right here. And I think I'm doing 2 here. And yours will be the same, right? This, given the vertex and the focus, find the standard form of the equation, right? So it'd be just like this, pattern what you do off of this. Okay, so given the vertex and the focus, write the standard form of the equation. Okay, well, there's a problem. Before you start, you kind of need to know which one you're using. Or is this the y equals x squared or the x equals y squared? And the way you're going to figure that out is draw a graph. I mean, just plot these on a graph and see whether you could figure out which way it opens. Right? If the vertex is at negative 1, 2, right? Negative 1, positive 2, right? That's the HK. And the focus is at negative 1, 0. That's here, right? That's your focus. Then which way is this thing opening up? It's down, right? Because we know that the parabola goes through the vertex and around the focus. So it's definitely a down. Right? And, you know, it does not say sketch the graph, but you kind of need to have that idea of whether it opens up, down, left, right. It opens down, which means we want this equation. X minus h squared equals 4p y minus k. That's the one you use if it's up or down. Okay, now we have to fill in which values there. H, K, and P. Okay, where are you going to get the HK from? I mean, it's given to you right there, right? This is HK. So you're just going to plug that in. H goes here, and K goes here. And then you need to be able to figure out what is the P. Well, just look at the little bit of a graph that I made there. Can you tell what the P is? P is the distance from the vertex to the focus. So what is this distance? P equals 2. Okay, well, it opens down, so what does P really equal? Negative 2. Right? So P equals negative 2. So that goes here. So let's plug in all that stuff. X minus negative 1 squared equals 4 times negative 2 y minus 2. X plus 1 squared equals negative 8 y minus 2. Done. What's that? These are, I think that, you know, the hardest thing you got to do in any of this is you have to complete the square before you can, you know, figure out what you're doing. But this shouldn't be that hard, but, you know, you need to sketch the graph. Right? It helped us to determine which standard form of equation and then what's the value of P. Right, so there's one more And this time, and you'll get the same kind of problem. This is the even number. You're going to do the odd one right next to it, where you're given the vertex and the directrix. Okay, so let's see. Before I can get started, I need to sketch those and see whether that gives me a clue as to which standard form, which way does it open. All right, so let's see. The vertex is at 1, 2. 1, 2. And the directrix is the line y equals negative 1. Right? Y equals negative 1 is this line right there. So this is directrix. And this is HK. Which means, which direction is this parabola going to open? Up, right? It opens up away from the directrix, right? So we know that it's doing this kind of thing there. Okay, so which standard form do we need? We need the one that's vertical, right? The one that's vertical would be x minus h squared equals 4p y minus k. As we've already seen, this is going to be the h, this is going to be the k. And then from the graph, can you tell what is the p? P is the distance from the vertex to the focus, from the vertex to the directrix. P is this distance. How far is that? 3, right? That is 3. P equals, well, is it positive 3 or negative 3? It opens up. It opens up. So should it be positive? It's positive. Right? Remember, for a vertical one, if P is greater than 0, it opens up, and this one opens up. So now we've got what we need. This is going to go here. So x minus 1 squared equals 4 times 3 y minus 2. X minus 1 squared equals 12 times y minus 2. That's standard form. Good. So, like I said, parabolas are something that you use. Okay, a parabola has this characteristic. It has the characteristic that, you know, anything that any kind of light source or radiation that hits the back of the parabola will be reflected exactly to the focus, right? And for that reason, it's used like in your satellite dishes. If you have a satellite television signal at home, then isn't there a thing that's sitting in the middle of it like that? Well, of course, your dish is reflecting all the satellite signal to that one point. It concentrates the signal to that one place. That is the focus of the parabola. The dish is shaped like a parabola in 3D, and it has the feeder horn there is right there at the focus. Now, it could be, you know, you could look at it and quibble with that a little bit, that it doesn't look like it's exactly, you know, symmetric or something, or the thing doesn't look like it's right in the center, you know, but I'm sure that as they change the shape a little bit, they preserve that quality of it's still reflecting. Everything that's hitting the back of that thing is being concentrated onto the focus, right? That's the whole point. So what do you think about the concentration or the strength of the signal? As the dish gets bigger, then you're concentrating more onto that one place, so you should get a better signal. Right? I mean, a lot of the dishes these days are pretty small, right? But the bigger the dish, generally, you'd be concentrating more incoming satellite signal into that one point. Another place where you use this, your car headlights. Right? Your car headlights have a parabolic shape at the back of it. And so when it shines, the light, which is sitting inside of that parabolic shape, it's reflecting off the back and then shining out the front of the car. Right? So that's also a parabolic shape. Okay. So that's what we did. Like I said, the homework, the first problems here are a matching. There's graphs and there's equations. Try to match them up. See what the vertex is in the equation and which graph has that vertex. Whether it's opening up, down, left, or right. Those kinds of things you'll be able to tell. Match them up. These here are, we did 5 examples. You have the odd number right next to the even number that I just did.